Welcome back to the Python crash course. Let's get started with part 1. I'm going to hop over to a new Jupyter notebook to get started. Let's start off our crash course with the very basics, starting with numbers. So Python has two main number types that we're going to be working with. It has integers, which are just whole numbers, or what is known as floating point numbers, or floats, which is essentially just with decimals. And if you ever want to check the type of any object in Python, you just use the type function. So I can say type 1. I can see there it's an int for integer, or type of 1.0. And since it has that decimal information, it's a floating point number, or a float. Let's go through some very basic math with Python. So all of this you would probably expect to work. 1 plus 1, so that's addition. Multiplication is just an asterisk, 1 times 3. Division is just a slash, so 1 divided by 2. If you want to do exponents, for example, 2 to the power 4, it's just 2 sets of asterisks. We can see that's 16. The modulus operator or mod operator is just a percent sign, as it is in various languages. So 4 mod 2 brings back 0. Remember the mod operator, in case you're unfamiliar with it, it just returns the remainder after a division. So 4 divided by 2, since 2 goes evenly into 4, it just returns 0. And for example, I can do 5 mod 2. That brings back 1 because 5 divided by 2 has a remainder of 1. And then quickly, order of operations is followed in Python. So for example, if I have 2 plus 3 times 5 plus 5, here it brings back 22. But if I actually want the addition to happen before that multiplication, I can specify a specific order of operations with parentheses. So here I'm going to say, hey, do the addition and then multiply them together. So now when I run the cell, I get back 50. The basics of variable assignment are also quite simple with Python. Python prefers snake casing, meaning if you have multiple words inside a variable name, you separate them out by underscores. So this is just by convention. There's no really strict rules on this, but we'll talk about this later on as well. But for instance, I can say equal sign. There's a name of a variable. So I can do this multiple times. So x is equal to 1, y is equal to 2. Run that, and then I can say something like x plus y, and there I get the variables. Okay, so we talk about numbers and variable assignment. Let's quickly talk about strings. So strings can be a single quote or a double quote. So there we see strings with both single and double quotes. And for instance, if you wanted to say something like, I don't like that, you could just wrap it all in double quotes. So I don't like that. And notice now, even though I have a single quote here, because I'm wrapping the whole thing in double quotes, I don't get any sort of error. If I had done this with single quotes, then Python is getting confused because it doesn't know where your actual string ends and starts. So it says, oh, is this the string or is this whole thing the string? So you can just mix up these quotes, double versus single, to actually make everything work correctly. Now notice here, I'm actually getting in an output cell, the string. If I want to actually display the string, I can print it, which means I can do something like print hello. And notice the difference here between just saying print hello or hello. If you're dealing with another IDE, you're going to be having to print your variables to see them during the output. For Jupyter Notebook, however, a lot of times it displays the very last line in a cell. So you can see here, it's just displaying that string. Versus here in this top cell in 20, it's actually printing out the string. So notice the difference here. There's no quotes, there's no out cell, versus here when I'm just asking for the string back, it returns the out cell plus the string itself. So that's printing, the very basics of it. Let's show you how to format print, which is essentially also known as string interpolation, which is a way to insert things into a string. For example, if I wanted to say something like, my name is, and then leave some sort of space there for me to input names, I could do curly brackets and then off of this string, call the .format method, and then I just pass in whatever I want to be there. So for example, I'll put in Jose. So we'll print this whole thing out. So put this entire thing under print, and now I can see it says, my name is Jose. So this is known as .format on a string, or string interpolation for a general sense, but it's a way to insert objects into a string. And the curly brackets there indicate what's going to be put in. Now I can do this with multiple objects, and the way I can do that is by actually naming them or ordering them. So we'll say my name is blank, and we'll say my number is, and then we'll also have curly brackets there, and then I'll pass in a second argument inside a format, and I'll put in something like 10, but let's put it in as a string so we don't get any errors here. Okay, so I say my name is Jose, and then it says my number is 10. So I'm passing in that string 10 and then putting it in here. Now, if I don't pass it in as a string and try to run this, it also works, but you should be careful with that. Sometimes you may get errors if you try to add stuff together inside the string. So I'm just playing it safe, passing that in as a string. So that's a really common thing to do. Another thing to do with format is to actually label these variables, which you'll also see. Let me show you a quick example of that. So we'll say first, and we'll pass in X, and then say second, and we'll pass in Y. So look what happens when I actually say, for these things, XXX, YYY. This is just to make it kind of really obvious what's happening here. Whoops, I get a key error because I actually labeled a key. So it expects a variable X to be inside format, and it will also expect some variable Y to be inside dot format. So let's add those in. We'll say X is equal to this triple X, and Y is equal to this triple Y. So running this again, now it works. So I see first, triple X, second, triple Y. So you might be wondering, well, what's the point of this? Well, now I don't need to worry about the order things are in format. Or I could use objects more than just once. For example, I could just say YY. Now when I run the cell, it says first YYY, second triple Y. Or I could reverse the order. Say Y is first, and then second is X. Running this, I can see now I have a lot more control by actually naming these variables inside of dot format. So that's the basic use case there. Let's move on to talk about lists. So lists are also known as arrays in other languages, and the way they work in Python is actually quite simple. All you have to do is use square brackets, and you separate the different items inside of the list by commas. So here I have a list of numbers, 1, 2, 3, but I could also have a list of strings such as A, comma B, comma C. So that's another list. And I can even mix data types. So I can say there's a number and there's a letter, run that, and Python doesn't complain. Now, if I actually want to grab objects from a list, I can use indexing. So let's show you how to do that. I'll create an object called myList and set it equal to a list of letters. So we'll say A, B, C. Now, as a really quick note, what you should never do is if you're typing a variable name and you notice that it's suddenly highlighted for you, then you're probably going to run into issues there because this basically indicates that this is some sort of reserved keyword. So if you notice that it's being highlighted, then you're having an issue. Now, if you've defined your own function and you expect that sort of behavior, then that's totally fine. But notice here it's being highlighted, so we're going to try to avoid using list as a variable name, which is a good call. Now let me zoom in just a little more here so we can clearly see what's happening. So I have my list. It's equal to these A, B, and C. Let's say I want to grab the very first item in my list, A. Well, I can just use an index call. So we grab the name of the list, add in square brackets, and then indexing starts at 0. So if I want to grab the very first item, that letter A, I pass in a 0 there, and it returns the letter A. If I want to grab the very last letter, C, I had two options. I could count over and say 0, 1, 2, and pass in the number 2, and I get back the letter C. Or let's say this was a super long list, and I just wanted to grab the last letter, but didn't actually want to count all the way through. Python supports negative indexing, meaning I can say, okay, starting from 0, go backwards 1, which is essentially saying loop all the way around and grab -1. And there we have C. Okay, so that's the basics of indexing with a list. If I ever want to change an item in the list, I can index it and then set it equal to some new item. So we'll say my list of 0 is equal to new. And if I run this, I don't actually see any output. So let's check if my list was actually changed by just asking for my list in the new cell. And there it is. I have new BC. So that's the way you can define a new or reassign an object in a list. Now, if I don't want to reassign an object in the list, but instead add on to that list, then all I have to do is use the append method, which appends a new item to a list. So let's show that. Going to clear that cell. Right now, I have my list, which is new B and C, but I want to add a fourth item, so I'll say append, and then let's add the letter D. to the end of the list. So I run that. I don't get anything back since the action is not actually returning anything, but it is affecting the list. So if I ask for my list back, I can say new, B, C, and D. I can also nest lists. So let me show you what I mean by that. I can have my list is equal to, and I'm basically creating a new list here, 1, 2, and then the third item can actually be a new list. For example, 100, 200. So if I look at my list now, I see I have a list inside of a list, and you can do this as many times as you want. However, be reasonable. You don't want to do a nest inside of a nest inside of a nest, etc. But if you ever want to grab an item from this list, for example, let's say we want to grab 200 just by itself. Well, I know that this list completely is the third item. So that's 0, 1, 2. So I pass in 2, and I get back that list, 100, 200, and I can actually stack index calls, meaning if I want to grab 200, well, that's index 0, index 1. So I just say this, 1, shift enter, and then I grab 200. So that's a nested list, and that's the way I can actually grab stuff from a nested list. I can just stack these index calls. So that's going to be useful if you're working with a matrix or something that has 2 dimensions. Usually that's represented as a nested list. So we'll see a little bit of this throughout the course, but it won't be anything too crazy. So that's the basics for all you really need to know about lists or arrays. Again, they're just a sequence of items or elements that are in order, meaning you can index them with a number. Now, let's talk about dictionaries, also known as hash tables in other languages. So dictionaries use this sort of notation. I'll say D is equal to curly braces, and then they have a key, which is always a string there, and then some sort of item. So this is known as a key value pair. So I'll have key, and then let's make a value 1. Then we have a comma there, and then we have key 2, colon, and then some second value. So I run that, and then if I want to access items from this dictionary, I pass in the key name. So what I want to do is access values based off of their key. So I'll grab a key here, key 1, and that returns value 1, which makes sense. And if I ask for key 2, then I get back value 2. So something to keep in mind that is sometimes confusing for beginners is that these hash tables or dictionaries in Python, they do not retain any order. So unlike a list, these guys don't retain any order. So whatever order happens to be printed out, so let's say I wanted to print out this dictionary, it may not actually be in the order that you would expect. So here, notice I get key 2, value 2, key 1, value 1, even if I defined it 1 and then 2. So again, dictionaries don't retain any order. And that really has to do with the way a hash table works, which you don't actually need to understand for this course. The basic idea is these are just key value pairs. So instead of items being in a sequence, they're matched up with key values as a pair. So you can easily access items based off their key. And this is a really great way to store things where you need really quick access. All right. Let's move on to discuss booleans. So booleans are quite simple in Python. It's just either true with a capital T or false with a capital F. Not much more to it than that. Now, as a quick note, a lot of programming languages, Python included, have what's known as truthy, which means if something is truthy or falsy, which essentially assigns some sort of truth or false behavior to a lot of objects. So for example, if you're ever working with if statements, which we'll discuss later on, and you don't really want to use a boolean, you can also use numbers. So zeros are treated as a false statement. So if you say if 0, it happens to be false, and ones are treated as a true statement. So if 1, then it actually does something. We won't see too much of that in the course, but if we do see it, I'll make sure to let you know. It's usually pretty obvious when you see it in actual coding, but that's something I want you to be aware of. Now there's 2 more data structures I want to discuss. That's tuples and sets. Tuples are very much like a list. They're a sequence of items. You'll notice here that they're defined by using parentheses instead of these square brackets that we saw earlier. Now you might be wondering, well, why use a tuple versus a list? Well, tuples are immutable, meaning you can't reassign the items inside of them. So I have T of 0, and if I try to set this to new like I did for a list, I will get a type error, and it says tuple object does not support item assignment. So you want to use tuples when you want to make sure a user can't actually change anything inside of this sequence. So that's the use case of a tuple. And then finally, the last major data structure of Python is the set. Looks a lot like a dictionary, except there's no key value pairs. It's just this sequence of items. So a set is an unordered collection of unique elements. So what does that mean? It means since all the elements have to be unique, if you add in multiple instances of an element inside of this set, it's going to reduce this to just the unique elements, which is 1, 2, and 3. All right. That's really all we need to know as far as the basic data structures, and we'll constantly be reviewing this sort of stuff as we continue on throughout the rest of the course. And a lot of the syntax we'll be using is mainly with Spark data frames, so this is all you really need to know. Coming up next, we'll discuss comparison operators, logic operators, and then how Python deals with if, else if, and else statements, as well as certain loops like for loops and while loops. Thanks, and I'll see you at the next lecture. Welcome back to part 2 of the Python crash course. Let's jump back to the Jupyter Notebook and get started. In part 1, we discussed all the basic data structures that Python has to offer. Now let's discuss some of the basic operators, such as comparison operators and logic operators, as well as discussing for loops and while loops. Let's start with comparison operators. Comparison operators just allow you to compare two different variables or two different numbers, two different strings, etc., and then get back some sort of Boolean value, either true or false. For example, if I want to check if it's 1 greater than 2, well, that returns false. Is 1 less than 5? That returns true. So let's walk through a couple more of these. I can do greater than or equal to. I can do less than or equal to. And then I can check for equality using two equal signs. So is 1 equal to 1? Well, that's true. And I can do the same thing for strings. Is A equal to A? Well, that's true. And note, this is case sensitive, so capital A equal to A, that's going to return false. Those are not exactly the same. And if you want to do inequality, it's just an exclamation point. So is 1 not equal to 2? Well, that returns true. They are not equal to each other. Now let's discuss logic operators. Logic operators just allow you to combine multiple comparison operations. For example, if I want to check is 1 equal to 1, well, that returns true. And if I want to check two conditions, then I just use and. And then in parentheses, I can put in the new condition. So I want to check is 1 equal to 1 and is lowercase a equal to lowercase a. Well, that's true. But for example, let me change just one of these. And that returns false. So I always recommend using parentheses whenever you use logic operators, but you don't actually need them in a lot of cases. So if I just run this, it will run fine. But I always recommend having parentheses. Makes it a little more readable, in my opinion. And it also makes sure that you don't get any errors. Okay. So that's the and comparison, or and logic operator, excuse me. And then there's the or logic operator. So a lot of times in other languages, these are either ampersands or pipe operators. Luckily for us, it's just simple English, OR for or, and then and for and. And you can do more than just two. You can kind of stack these on. So we'll say and, maybe, I don't know, 3 equals to 3. That returns false again. So let's change one of these to be 1. Run this, and then that's true. So that's really all we need to know about logic and comparison operators. Now let's discuss if, elif, and else statements. So these are essentially just if, else, if, and else statements. This is quite simple in Python. All you have to say is if, and then whatever condition you want to check. So for example, if 1 is equal to 1, colon, and you notice when I hit enter, I get an indentation there. So Python depends a lot on white space. So unlike other languages that will separate these sort of code blocks with curly braces, Python just uses white space and indentation. That's why a lot of times it's recommended for beginners, or a lot of people really like programming in it because the sort of white space makes things readable and makes things very simplistic. So if 1 is equal to 1, I want to print, I don't know, yeah. And then we get out, yeah. So let's say if 1 is equal to 2, print yeah. If I run the cell, I don't get anything back, which makes sense because 1 is not equal to 2. So that's a simple if statement. Now let's show you an if-else statement. So I can say if 1 is equal to 2, print worked. If I want to add an else to this, then all I have to do is line up the else with that if, and else doesn't have any condition because it's kind of a last case thing. And then we'll say nope. And let's make sure that's all in a string. And then shift enter, and I get back nope. So if 1 is equal to 2, well, that never executed. So then we get else, print nope. If you want to check for more conditions, then you just add in an elif. So that's elif right there. And then you can add in a condition. And this condition doesn't need to be in parentheses. So a lot of times in other languages, you would see a parentheses here and then some sort of a condition check. In Python, you don't actually need it. Everything just works off that colon. So here I'll say elif 3 is equal to 3, colon. And note when I hit enter, there's automatic indentation there. I will print second condition true. So I run this and I get second condition true. Great. So that's really the basics of an if, elif, or else statement. So moving along, let's talk about for loops. So for loops in Python are actually quite simple. You can for loop through a lot of different sort of sequences or objects, including lists, dictionaries, and tuples. We'll just focus on lists since that's basically what we're going to be using throughout the course. As far as for loops, so we'll say a sequence, 1, 2, 3, and let's add a couple more numbers, 4, 5. So there's seq, it's just a list, and I'm going to say for item in that list, which is sequence, colon, note the indentation, and then we can do something, such as print every item in that sequence. And now that gives me back 1, 2, 3, 4, 5. Now, common point of confusion for newcomers to Python is, does it have to be this keyword item? Well, actually, no. This can just be any temporary variable name that you want. So let's make it really obvious by calling it jelly. And if I run this, I get back the exact same result. Perfect. So I also don't actually need to use this variable. So for example, I can say for elements in sequence, print hi. And then if I run this, I get hi, etc. And then I can also use something like element plus elements, and then I get 2, 4, 6, 8, 10. So basically doubling each element in that sequence. So that's all you have to do for a for loop. It's just for, then whatever temporary element variable name you want there, in, and then whatever sequence you're using for that for loop. Quite simple. Now let's discuss while loops. So while loops keep running while a condition is true. So I will say I is equal to 1, and then while some condition, for example, while I is less than 5, and currently it's set to 1, so that makes sense. I will print I is curly brackets, and then I will say dot format, insert I there. And then I don't want this to run forever, so let's say I is equal to I plus 1. Then I do shift enter, and I get 1, 2, 3, 4. So what's actually happening here? Well, I is equal to 1, and while this condition is true, I less than 5, I'm just going to print out I is currently I, etc. So it goes 1, 2, 3, 4, and on that very last one, it says, okay, well now 4 plus 1 is 5, so I is no longer less than 5, it's actually equal to it, so this loop ends. And that's the basics of a while loop. Let's discuss two more things, a range function and list comprehension. Often, you'll want to quickly create a list of integers. So for example, a lot of operations, it's really common to do something like 1, 2, 3, 4, etc., and then loop through a certain number of items. But you can actually really quickly create a list that looks like this using range. So for Python 3, if I just say range of 5, it just gives me back this sort of range generator, but I can cast it into a list, and it gets me back a list of integers. And I can actually specify the starting point and the end point. So if you're ever confused on what a function actually does, you can just, again, use Shift-Tab, and it will tell you the docstring. So it's quite easy. So range, you can say stop, and it gives you back that range object. Or you can also say the start and stop. And you can even indicate a step size. So let's see that in action. I want to start at 2, and let's go to 5. So something that's kind of confusing for beginners is why is 5 not included here? Well, you can think of it as basically up to but not including 5. So it only goes to 4. So we say the stop is up to but not including that integer, that last integer. And the reason for that is because indexing starts at 0. So you can almost think of it as kind of taking away 1. All right. So that's the basics of range. And you'll commonly see range used in a for loop without this sort of list call. So you can say for x in range 5, and then we'll say something like print hi. And there we see hi, 1, 2, 3, 4, 5. Okay, so this is 0, 1, 2, 3, 4. So 4 is up to, but not including 5 there. And that's the basics of range. And we'll see it every once in a while, not too often throughout this course, but it's common enough that you should know it. Finally, let's discuss list comprehension. So list comprehension is a really useful feature of Python. Often you'll find yourself trying to build out a list. So let me show you an example of that. I'm going to create a list, 1, 2, 3, 4, 5. And then I will say out is equal to an empty list. So just those square brackets. And I'm going to say for num in x, take out and append that number squared. And then outside of this for loop, note my indentation, how it's lining up with that for. So once that for loop is done, I'm going to print that out list. So let's run this. And we get what we expect, 1, 4, 9, 16, 25. So what am I doing here? Well, I have out as my empty list, and I'm saying, for every number in the x, append the squared number of it. And then at the end, print out that entire list. So 1, 4, 9, 16, 25. This sort of action is so common in Python to build out a list this way that they've actually created essentially a shortcut, a way to flatten this out into what's known as a list comprehension. So I'm going to convert this sort of for loop into a list comprehension. And the way we do that is we say, put everything inside these square brackets. And then we start by saying num to the power of 2, or whatever you're trying to append. And then we say for num in, and then the iterable was x. And if I run this, this gives me back the exact same thing that this for loop did. So you can think of it as just another way of writing out a for loop that particularly creates lists. So if you ever find yourself constantly appending to a new list inside of a for loop, you may want to consider list comprehension as a possible solution just to flatten this out. As far as readability is concerned, for newcomers, this is not as readable as a for loop, but once you end up working with Python a lot, you'll end up preferring list comprehension. It's slightly faster. There's a very tiny performance boost there, but for certain situations, it's negligible. So, okay. So that's really all we want to discuss for part 2. Coming up next, we'll discuss functions, Lambda expressions, and then methods as well. Okay. Thanks, and I'll see you at the next lecture. Welcome back to part 3 of the Python Crash Course. We're going to end things here by talking about functions and some special methods you can use off of Python objects. Let's jump back to that Jupyter notebook and finish up. All right, let's start off by talking about functions and how you can create your own custom functions. The keyword when creating a function is def, and then whatever you want to call the function. So we'll say my underscore func for func. And this is going to be a really simple function. It's not going to take any parameters. We have the colon there. And then whatever you want to have happen when you call a function. So for example, print hello. And then make sure to run this. So now the function's been defined. I can see here the cell's been run. And then I can actually call my func. And I see hello back. Now a common point of confusion sometimes is you'll just type my func, run this, and it will report back what the function actually is. So it'll say, oh, my func, that's a function. It's in the main file, .myfunc. What you actually want to do is if you want to execute the function, have those open and close parentheses there. If you would like to add parameters to a function, for example, let's give a parameter name, then it will intake, for example, hello, and a simple way can pass that in is plus name. So now I'm going to run this, redefine it, and then say myfunc and pass in Jose. If I run this, it says hello, Jose. So what that's doing is concatenating these strings together. So that's a little special method you can use for strings. And I can add a space in there, run these two again. Now I see hello, Jose. If I don't actually provide one here, I will get an error. It'll say type error, and it'll actually say, hey, I'm missing one required positional argument called name. If you want to have a default parameter or argument value, you can just say names equal to, and we'll say for example, no name. And then I'm going to run this. And now, if I just pass this in with Jose, it will still work. I'll say, hello, Jose. But if I, for some reason, forget, it's going to go to the default value. So I can run this, and I'll say, hello, no name. And that's the basics of functions. And real quickly, if you want to have a doc string in your function, you can do it with a set of triple quotes. It's going to be either double or single. And this is where you can describe what the function does. So I can say something like, this prints out the username. And then I'm going to do Shift Enter to run that. And now, with my own function, I can do Shift Tab, and I'll say the signature of the function and then the doc string. This prints out the username. So I can see here that it actually looks for the documentation string for this function whenever I call Shift Tab, which is kind of a nice feature. All right. So let's actually show you one last function that will kind of show a more realistic example. So I'll say def square, and it takes in some value x, and then it's going to return x. So what's the difference between print and return? So print just displays the actual value. Return allows you to save the actual object or whatever the function happens to do and save it to a variable. So my little function here, square, is going to take some sort of number x, and then it's going to return the square of it. So I'm going to say result is equal to square of 2. And then if I check on my results, I notice that it's 4. So with the return keyword, I can actually save this as a variable. If I just printed this, so if I just said print and put that there, then what would have happened was I would get none back. So if I rerun these, I get back nothing as a result. So notice it says result is equal to square 2, and when I run this, it prints it out. But then when I ask for what result was, it's actually none. And if you check the type of result, it'll say it's a none type. The reason for that being is that it only printed out the value 4. It didn't actually return it. And the only way I can save it is if I return it. So the only way I can do the assignment to a new variable is by using that keyword return. Then rerunning all this, notice if I run this again, I don't actually see the printed out result because I was returning it in order to save it to this variable result, which means I have 4, and if I check the type of result now, I get this integer type. Okay, now let's discuss lambda expressions. Lambda expressions is just a way you can quickly type an anonymous function. That's also another name for it. Essentially, if you only plan on using a function one time, maybe you don't want to rewrite the entire function, give it a formal name, use def. You just want something kind of quick and easy. So the way you can do that is, for example, if I have def, we'll call this times 2. It takes in some variable, var, and then it's going to return var times 2. So for example, I can say times 2, and notice I can use tabs to autocomplete that, so it's a little faster. So it says times 2, and it returns 20 for me. Notice that it's returning it, not printing it out. So I have that a little out next to that cell. The way I can use a lambda expression to rewrite this is the following. Use the lambda keyword, the input, colon, and then you want what you want the output to be. So for example, var times 2. And now this will behave really similar to the function. For now, it's not really clear how to use these. We need to use these along with another outside function. So we'll talk about this later on in the course when it shows up, but I just want you to be aware of what the lambda expression is, essentially an anonymous function. So it's a different way of rewriting this whole thing in just one go. But the issue here is I can only call this one time. I don't have a name assigned to it. So what's the actual relationship between this and this? Well, I can kind of convert this function to show you. First thing I need to do is take away the name, take away this def keyword, replace it with lambda, take away these parentheses, take away the return keyword, and then put it all in one line. And that's how you can convert a function to a lambda expression. And later on throughout the course, if we ever use a lambda expression, I'll touch in a little more detail on how we actually use this. I just want you to see it for now. All right. Moving along, I want to talk about a few methods that are going to be useful to you throughout the course. So methods on strings. I'm going to create a string called st, and it's going to say hello, my name is Sam with a capital S. If you ever want to lowercase everything in a string and just say s.lower, close parentheses here, and it returns back everything lowercased in that string. So notice here, S on Sam has been lowercased. We've seen upper before. It's the exact same thing, except it uppercases everything. A really useful method is split, which is going to split by default on white space and return a list. So it splits that string into a list based off the white space. If you actually want to split on a particular string value, you can clarify that as well. For example, I'm going to create a tweet here, and later on we'll see how we can do Spark streaming for tweets. But I'm going to say hello, hashtag sports, run that. And then I'm going to, if I just say split, by default, it splits on white space. So it splits hello and then hashtag sports. But maybe I actually want to split on hashtag, so I want to analyze Twitter somehow. Well, I can just pass in hashtag there, and then it's going to split on the hashtag. And notice how now the hashtag is no longer in this list because that is what was split on. And then if I want to grab the actual item from this that was in the hashtag, assuming that the hashtag is all the way at the end, I could just say something like -1. And then that returns the string sports. Obviously, not every case will have a hashtag all the way at the end of the string, but this is kind of just to show you a little more realistic of an example of how you can actually use split. Okay, a couple more things I want to show you is how you can grab the keys and items of a dictionary. So just quickly now, if I create a dictionary with K1, V1, so key 1, value 1, and then maybe K2, V2. If I want to grab all the keys in the dictionary, I can just say d.keys, and I get this dictionary keys where I see K1, K2. If I want to grab all the items, I can just grab these kind of tuple item pairs. So K2, V2, K1, V1. Note that the order here is not retained. Again, dictionaries do not retain any order. We won't actually see these basically at all throughout the course, but just something to be aware of in case while you're using a Stack Overflow or something, you kind of run into these on your own. Finally, I want to show how you can pop something off of a list or check if something is inside of a list. I'll say my list is equal to 1, 2, 3. If I want to grab and remove the last item in a list, I can say a new variable last is equal to my list and then say .pop, close parentheses. And now if I check my list, it's missing that last item, that number 3, and I've saved it to this variable last. So that's how you can remove an item from a list, at least the last item. If you want to remove an item at a specific index, you can just pass that in to pop. So for example, let's redefine my list again as 1, 2, 3. So if I check my list, I have all 3 numbers there. And then I want to pop off the first element. Well, I'll say pop and then pass in the index 0 to indicate that I want to pop off the first element. And I'm going to save that as now first. Run this. I can check my list, just have 2 and 3. And then I can check first and it's 1. If I want to check if an item is inside of a list, I can just use the in operator. So I can say x in 1, 2, 3. That returns false. If I ask for 1 in the list 1, 2, 3, that returns true. So I could also say something like 2 in my list that I defined earlier, and that also returns true because my list is now 2 and 3. Coming up next, we have a really quick review exercise notebook that's optional in case you just want to clarify and make sure that you really understood everything we were talking about here. Totally optional. You don't have to do it, but it would be a quick review just to confirm that you understood everything and you're ready to go to talking about Spark and Python and data frames and all that cool stuff. Thanks, everybody, and I'll see you at the next lecture.